Alright guys, this next problem says borium-267 has a half-life of 15 seconds. Find the amount that remains from a 16 milligram sample of this substance after 2 minutes. So let's break this information up. Well, I see that this, whatever we're looking at here, the substance has a half-life every 15 seconds. And we want to find the amount that remains, what's remaining from 16 milligrams, our 16 milligram sample, of the substance after 2 minutes. So what's remaining after 2 minutes? All right, so let's go ahead. I'm going to write an equation in words first. So if we look below here, we have the form of an exponential function, but I want to write this equation in words first. I'm going to think about this function in words first. So first off, what I want to do is say, well, f of x, well, that's what I'm looking for here. So f of x, what am I looking for? Well, how much borium-267 is left after 2 minutes? So I'm going to write I'm just going to write that out. Borium, B-O-H-R-I-U-M, borium-267. Yeah, in fact, if you wanted to, you could probably just write how much is left after 2 minutes or something. But borium-267 after 2 minutes. In fact, I'm going to fix that to 2 minutes. And another way of thinking about 2 minutes, just because I'm seeing that this problem has 15 seconds, another way of thinking about 2 minutes, you might want to just make a mental note that that's the same as 120 seconds. You might be converting time or using this information at some point. So either 2 minutes or 120 seconds, we're still talking about the same duration of time. I'm just going to create square brackets around that information. All right, and I want to fix that last square bracket there. There we go. This is equal to, okay, this is equal to, all right, this is equal to my a sub 1. I'm going to think of that as my initial value. So it's equal to my initial value, my starting value. All right, that initial value. All right, and I'm not going to put a multiplication symbol here. I'm just going to open up another set of square brackets in a second. All right, so this initial value times r. Well, what's happening to this initial value? Well, it has a half-life. It's halving. So, in fact, I'm going to write times its half-life, or halving here. I'm dividing it into 2 repeatedly. So it's halving. So the initial value times, and that's what these square brackets are telling me to do, kind of like parentheses, or in fact, exactly like parentheses. These square brackets are going to tell me that I'm going to multiply the values inside of the square brackets together at some point. So halving, cool, halving. And the last part is, well, how many times is this happening? What's that duration of time? So raised to the power for a specific duration of time. Duration should be an A-D-U-R. Duration of time, and I'm going to put square brackets around that. Raised to the power of a specific duration of time. Okay, so how much is left after 2 minutes? Well, that's simply just that function notation, f of x. So I'm going to lead with f of x is equal to that initial value. The initial value in this case, it's 16. That's the starting sample. So 16, and I'm going to put parentheses around that. Okay, since I'm going to be repeatedly dividing this initial value by 2, I'm having it. I'm not having it. I'm halving it. I'm repeatedly splitting it in half. So what I'm going to do here is write 1/2, and wrap that in parentheses. And so I'm repeatedly splitting it in half for a specific duration of time, and that duration of time is 2 minutes, but it's being split in half every 15 seconds, and we want to see how many times 15 seconds will go into 2 minutes is basically what we're saying. What's that duration of time going to be? Okay, so you could probably just calculate this in your head, how many times 15 seconds goes into 2 minutes. But another way you could actually visualize it mathematically here is, well, 15 is, it's 1/4, it's a quarter of, and I'm going to fix that, 1/4 of 1 minute, or 60 seconds. So 1 minute, in fact, I'm going to erase that, 1 minute, or it's 60 seconds. 1 minute or 60 seconds. So if I were to take 60 and divide by 15, I would get 4. Or if I were to take 15 and multiply by 4, I'd get 60. But since 15 is a quarter of 60 seconds, or 1 minute, then 15, it's an eighth, it's 1/8 of 120 seconds, 120 seconds. And what this is telling me is that 15 goes into 120 seconds 8 times. So that duration of time, or the amount of times that our substance will be halved, well, it will happen 8 times in a 2-minute period. So this is 1/2 raised to the 8th power, and I'm going to fix that 8. Okay. All right, so we have f of x, it's equal to 16. So we have 16. So 16 times 1/2, and both of these are going to be raised to the 8th power. So first thing I'm going to do is just wrap these in parentheses, and then I'm going to bring that power of 8 inside the parentheses just to look at it real quick. So times 1 to the 8th power over 2 to the 8th power. All right, so now we have f of x, it's equal to 16. So 16. And in fact, I'm going to get rid of those parentheses and just say 16 times 1 over 2 to the 8th power, or 1 to the 8th power is 1, and 2 to the 8th power is 256, so 256. Now, I can think of 16 as a fraction as 16 over 1, and I'm going to multiply these two fractions. I'm going to multiply straight across on top and straight across on bottom. All right, so now I want to run through the next step over here. I have f of x, it's equal to, I'm going to fix that parenthesis, equal to 16 over 256. And let's fix that 5. Okay, so 256, and this can be simplified. All right, so what I have here, f of x is equal to 1/16. So I have 1/16, or I could actually turn that into a fraction, or a decimal. Turn that fraction into a decimal as 0.0625. So 625. Okay, so what's this telling us about f of x? Well, f of x, remember, f of x is telling us how much barium-267 is left after 2 minutes or 120 seconds. Well, we started out with 16 milligrams, so after 2 minutes, we're left with 625 10,000ths of a milligram. So 625 10,000ths of a milligram is definitely less than 16 milligrams. So this is an example of exponential decay. We started out with a larger amount and then rapidly shrunk to a smaller amount. Cool. I'll see you in another video.